Okay, so I've asked you to graph the function at 1/4 x plus 2. So we're going to start at 2 on the y-intercept, go up 1 over 4. Here's my line, straight line. And then I'm also going to graph this F inverse. So I'm going to start at -8, up 4 over 1. Okay, so reviewing inverses from previous course. If they are inverses, they will be symmetric or to each other. They will reflect. Sorry, I forgot what I was looking for. They will reflect in the y equals x line. So y equals x is where x and y in the ordered pairs are the same number. 1, 1, 2, 2, 3, 3, 4, 4. So you can look at my two graphs and say, if I folded the graphs on y equals x, would all the pieces match up? And they should. And another thing that you will notice when we have inverses is when I take any ordered pairs, for example, this one, which is 8, 4, there is a corresponding ordered pair that when I fold these together, that matches up with it. It's going to be this one over here, which happens to be 4, 8. I'm going to do that again. I'm going to take this ordered pair here on the pink line. So that's 1, -4. And when I fold them together, I get this point on the black line that is -4, 1. And it doesn't matter which set of ordered pairs you choose. The x's and y's switch for every single point with its corresponding point when you fold it over that y equals x line. So you can tell that graphs are inverses because they will reflect in that y equals x line. If you see their ordered pairs, you just switch x and y. Everything switches if it wasn't lines. If we were talking about other things, the domain and ranges would switch. Lines, they switch, but they're both all real numbers, so you can't really tell. But you'll see it with other graphs. Any questions about that? Then what I just said is all written in here. The next is an example, which you don't actually have to, you don't have to do anything, but just look at it. The example is the equation f of x equals 2x plus 3. And if I were to plug something in for x, if I were going to just put a number in for x, I would first multiply that number by 2, then I would add 3. This g of x, this is the inverse, which we will write as f inverse of x. But this book used g of x because it's another equation. X minus 3 over 2. If I were to plug something in for x, the first thing I would do would be subtract 3, and then I would divide that whole thing by 2. Well, if you notice, multiply by 2, and we talk about what undoes multiplication in math. You would divide by 2. Well, here it is. That is called an inverse operation. If we talk about add 3, what's the inverse to adding 3? Subtracting 3. And then you'll also notice that these are in a different order than these. They're in like opposite order. This is true about all inverses. So you could almost look at the equation and just be able to write the new equation knowing what order you would do something to the x. If I know I would multiply by 2, then add 3, well, I'm going to switch the order and I'm going to do the opposite operations. Subtract 3, divide by 2. And then write that equation. I'm going to do it algebraically. I'm not going to really do it mentally, but you can do it mentally. One more thing about these. If I did add 3 and subtract 3, what happens when I add 3 and subtract 3? What do I get? I get 0. What happens when I multiply by 2 and then I divide by 2? I get 1. Okay? Now, in this case, it wouldn't necessarily be 1. It would be whatever x is. So I'm not going to say 1. I would get x. Okay? If I add and subtract 3, I would get 0 plus x. If I times by 2, divide by 2, I would get 1 times x, or divide by x, or x divided by 1. Same thing, times 1. So when we do inverse equations, that's why the center is at y equals x, because everything undoes itself, and it goes all the way to 1 for the slope and adding nothing on. That's where that middle is, where it undoes itself. Here you can see the 2 graphs that we were just looking at. The 2 equations are graphed. Looking at their ordered pairs, all the numbers are just the x and y's are switched. And you can see the graph, it is reflecting in that y equals x line. And then I already talked about everything that's written there. Okay. So the first equation is doing a linear one. But I feel like we just did that. So I don't think we need to go over the linear equation. Is that okay? Can we skip over linear? Okay. Next is nonlinear. So this is where we'll start. Now, I'm using the word functions, and we've been using the word function a lot in Chapter 1. We're going to write our maybe we can do this mentally real fast. We're going to write our inverse as a function, but only if it is a function. So a line, when I find the inverse of that, it's going to be another line. Those are going to be functions. Can we maybe try to mentally figure this one out? If I multiply by 3, then I subtract 1, what's the first thing I'm going to do in the inverse? Add 1, and then what? And then divide by 3, the whole thing. So that would be our inverse. Look. That was easy. We could do it mentally if we want. Sometimes. Okay, but what was I saying? Oh, just if it's a function, please put it in function notation. So here are 2 graphs of the original function and its inverse. And we look at the original function for f of x equals x squared, that quadratic, and then we look at the inverse that is reflecting in that y equals x line. And is its inverse a function? No, because it does not pass the vertical line test. So because it's not a function, you will not see me writing f inverse, f to the negative 1, which is not to the, but f inverse. You won't see me writing this because it's not a function. So what do we write instead? We just write y equals. Okay. So what would y equals? Right now, they have x equals y squared. That is the equation of that red opening to the right parabola. But I want to write it as y equals. So how can I do that? Gavin, can you help me do that? The equation's in red. I just want to change the order of, Perfect. Yeah, we're going to square root both sides, and we do need that plus or minus. So that would be the equation. But again, it's not a function, so I will not write that f negative 1 thing, because it's not a function. What undoes squared in equations? If you have a squared, you need to get rid of it. What undoes that? Square root. And when we graph a square root function, does it look like a sideways U? So how come this one looks like a sideways U? Who was that? Was it Gracie?
You have the positive and negative.
Because I have the positive and negative, which I do have to have. So I want you guys to understand that if we have a full quadratic equation, its inverse is the entire positive and negative square root. So it has that positive square root and it has that reflect in the in the x-axis square root. It's got both of them. The things that we have been doing were already given to you as either a positive or a negative to start. You didn't actually have to solve them prior. So that's why we were only getting the half of it. Okay? Cubic or cube roots and cubic, they are functions. The blue, it's a little hard to tell until you can actually see the color difference. Can we see the color difference? Can you see it? Okay. Just want to check. So the blue one that has the arrow pointing to it, f of x equals x cubed. The red one, I'm going to rewrite so it looks like it is an inverse rather than just some random function. It is a function, so I'm going to write f inverse. Oops, I forgot the no. Let's try that again. F inverse of x equals cube root x. So that's how I would write the function for that one. And that one is a function again because it passes the vertical line test. So what if we just need to find, oh, nope, I'm not there yet. Just kidding. Let's practice with a quadratic. Now I'm going to show you how I would do it. You certainly do not have to do it the same way as me, but I'm going to show you how I would do it. We have to find the inverse, and we have to graph the function and its inverse. So we're graphing both of them. We have to find the inverse. I'm going to do the graphing first. As crazy as that sounds, I'm going to do the graphing first. And I'm going to do it using transformations because I have a lot of people that still don't understand how to do the tables. I honestly would not use a transformation table for this one because it's just 4 to the what? 4 to the left. But I'm just going to review the transformation table for those of us that don't get it still. Because that would be something you need to know for your test. So if I were making a transformation table, I would start with my parent function. You want to do these as fast as possible. You want to understand transformations. So this is my parent function. My original vertex is at 0, 0. Now I'm going to transform it. You guys told me left 4, so I'm going to subtract 4. I didn't leave a lot of space. And then I can get rid of the original x's and just use the new x's. So where is my new vertex? So my new vertex is at negative 4, 0. So it's in that same line still. If you're just picking random numbers and plugging it in, you can't always find where the vertex is or the point of inflection or whatever important piece of information. You need to know where the center of that parabola is. Okay, there's something else that I just totally ignored for a moment, but we need to go back to. You guys see this part right here? What's that mean? Who knows what that means? Tyler, do you know what that means? Did I already pick on you, Tyler, today? Oh, okay. Right, that's what it says. What does that mean? So I'm about to plot these points. What does that tell me about these points I'm about to plot? A little bit louder, I can't hear you, hon.
No solution for those that are greater than or equal to -1.
Oh, it's not no solution, but it just means you're not allowed to graph these. It means you can't graph those. It's not part of the graph. Okay, so I'm just going to graph the ones that the x's are greater than or equal to negative 4. So if you can graph that, you should be able to graph the inverse now. So I'm going to draw that y equals x line so we can just kind of make sure it looks right. You should be able to graph the inverse now. So how do I graph the inverse? I don't even know what the equation is. Marie, what do I know about the inverse from the previous page? Right, so don't I have some x and y values? I do. So all I have to do is take those values and go and switch them. So now I can graph 0, -4. Oops. 1, -3. 4, -2. And 9, -1. And then we look at our graph and we say, does it look right? Does it look like a reflection? If the answer is no, then I need to go back and look what I'm doing. But it should look like a reflection. So now how do we find the equation? So there is that mental part, but I'm going to show you algebraically how you find it. Yes, so let me start though, because there's no y. There's no y. How can I switch the x and the y when there's no y? F of x is y. So the first thing I'm going to do is I'm going to think of f of x being y. Now I'm going to write the inverse. Here it goes. Here's my inverse. Done. I did it, right? And yes, not for x, but I'm going to solve for y. But that, what I just wrote in blue, you could type the blue one into Desmos and it will graph it for you. Like, that will graph it. You cannot type that in your graphing calculator to graph it. So we do need to solve it for y. Also, as I'm solving for it, is it a function, the blue one? So in order to write it in function notation, it has to be solved for y. So we can put that f of x in there. So what are we going to do? We're going to square root both sides. Yeah? If I do the square root, though, we've got a plus minus. I'm going to subtract that 4. I don't know why I wrote a 2 there. There we go. Okay, so this is the equation that I got when I solved it. If I were to graph this equation, would that make the blue graph? Who said no? Who's arguing with me? No, I'm just joking. Brandon, why? Because if I have a plus or a minus, that's going to be an up and a down part. It's going to be the up and the down. Abigail?
You need to put the restriction, right?
Okay, I can put the restriction.
Because they can't be lower than the two.
Right, that's true. So I'm going to do it a different way then. I'm actually not going to write this one with a restriction. I'm going to write it a different way. You ready for this? You guys are ready? You ready? Okay. So I'm also going to put it in function notation while I'm doing it. This is what I'm going to write. What'd I do? I got rid of the bottom half, which already took out the fact that x has to be greater or y has to be greater than equal to -4. They just happen to correspond to each other, so I was able to just like take this out and get rid of this negative. They kind of mean the exact same thing. So I'm just simplifying the way it looks, and I write it this way. You could also write it like square root of x and then -4, and that way you can tell that this was a square root that just went down 4. But usually we write it in this form only because it's confusing to know if the -4 is under the radical or not. That's usually why we write the number in front. What, hun? Not if there's an addition sign. right? Now, if it was just 4 next to it, then that would be a stretch. I mean, I would take either of these answers. Okay? All right, so now there's something called the horizontal line test, and that is a test that you can do on the original function, so you don't actually have to graph the inverse to tell if the inverse is a function or not. So using this parabola, if I use a horizontal line, that is going to tell me that when I inverse this parabola, that a vertical line would hit more than once. Doing a horizontal line test on the original function will tell me if the inverse is a function or not. And example 3, we're going to use your graphing calculator, and you're going to type that in, and you're going to see if it breaks the horizontal line test, and you don't even need to find the inverse to do that. So go ahead and grab your graphing calculator. Who is not prepared, who doesn't have their graphing calculator, use Desmos. This is like, just like a month. Desmos, who else? Desmos. Okay, so go ahead and graph that. I will use Desmos also because mine's under the camera. X to the 4th minus 4x squared. Type it in your graphing calculator. Make sure you know how to graph it on your graphing calculator. When you graph it on your graphing calculator, you should get the same picture that I have on Desmos. And the question is the inverse a function? I don't have my mouse on, sorry. Are you able to graph? Are you able to graph? Okay. Are you able to graph it? Yep. Are you able to graph it? Okay. You guys have any issues with graphing? You need to do that. But you can still see it, okay? Hit zoom 6. If you turn it off, it'll fix. Hit zoom 6. Did you get a graph? Yes. Everybody has a graph. Trying to help you if you're having any calculator issues. If your window's all wonky, zoom 6 will fix it. So, is the inverse a function? No. And we can look for horizontal hitting twice or more. Hitting more than once, I should say. If the horizontal hits more than once, it is not a function. Look at this. Boom. There we go, got it graphed. I can draw my horizontal line. Nope, not a function. So why or why not? Fails the what? Yeah, horizontal line test. Well, I should say I shouldn't say no fails the, I should say no the function, the original function, the f of x fails the horizontal line test. Okay, next, finding the inverse of a cubic function. So, and we also need to determine whether it is a function. We're going to do it without graphing. And we're going to find the inverse. So let's find it algebraically. First thing you need to do is switch x and y. So if my original question is y equals 2x cubed plus 1, I switch x and y. X equals 2y cubed plus 1. And I have my inverse. But solve it for y. I'm going to be quiet for a moment. I want you to go ahead and finish this. See if you can find the inverse. I'll pause the video for a second so it's not just dead space.